Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my beautiful and lovely co-host.
Ben Wilson.
Cool. Yeah, his name is just Ben. He doesn't have any background. And today we are speaking with machine learning engineers at Lyft, Deeksha and Michael. While getting her master's degree from Stanford in computer science, Deeksha interned both at Google and Lyft. She also co-founded a startup, and then while she had some free time, she served as a teaching assistant. And currently she's the ML lead for estimated time of arrival prediction. Michael studied at UBC, and after graduating, he held software engineering positions at SAP, Amazon, and most recently at Lyft. And he works alongside Deeksha, focusing on ETA and routing. So, Michael, kicking it off with you. Before we get into the technical, what is Girl Smarts?
It's a great question. I didn't know you would dig that hard back. It's a volunteer program of teaching girls in grade 5 to 7 how to code. And we had a few programs. We had like a software like engineering where we just teach them how to code in very basic coding languages with some if statements and stuff. We also had a UX design program, which was the one that I led and developed the program for. Basically, you draw the UX on a piece of paper and you take photos on an iPad, and you can link pages together on an app, sort of develop a user experience that way. But yeah, it was basically a fun program to get girls engaged into the life of computer science. So hopefully that they will take up a career in that when they grow up.
Awesome. And you've been doing it for 11 full years?
No, that was, I probably should update my LinkedIn. I did that through my undergrad, and I kind of had to stop after I graduated because that program was in Vancouver where I studied, and now I'm in Seattle, so couldn't really do that. Yeah.
Cool. All right. Well, yeah, I was just curious. When you peruse, you see stuff. But Ben,
Got a
it seems
question
like you
about
have a
that, though.
question.
Based on your experience of doing something like that, where you're taking a complete novice and introducing them to a complex technology stack or the concept of building something, did you learn things and notice things while you were doing that instruction that informs UX design or API design later on in a career to say, I'm sort of recognizing patterns that were hard for me to explain and teach to somebody to learn, so I shouldn't build software like that later on?
That's a great question. I think it's less translatable for me just because I mostly work in backend and UX is more so on the front end. But I've definitely noticed when somebody starts to do UX, they question everything. Like, why is the close button on the top right? Why couldn't I put it on the bottom left? Those are the things I never think of and I take for granted. But these kids, they question things, and it makes me question things as well, and why they are designed such way. So that's one example. And also, like, they would ask, oh, why do I need to go through different screens? Why can't things just happen on one screen? It's also like another question that they come up with through that exercise. So I thought that was pretty fun to learn.
Yeah, you definitely notice when you're entering a new environment, like as a professional or whatever it might be, you question organizational things that just are like embedded and everybody takes for granted. And yeah, I would love it if the exit button on my Chrome window was in the bottom left. That would just be truly game changing.
Yeah,
But
absolutely.
so, what is ETA? Can you explain that as a concept?
Oof. To a 3-year-old or to someone who's somewhat familiar with technology?
In the context of Lyft, like estimated time of arrival, all right, I'm going to get there in 5 minutes, but what implications does that have for the business?
Yeah, that's a great question, and Deeksha probably has a lot of things to add. But at a high level, ETA goes into a lot of decision making that we do at Lyft. So how to set the price, how to set who to match to who, so matching decisions, and as well as all the ETAs that we display to the users. for how long potentially a car might be able to approach you at the pickup location without knowing who the driver is going to be. Because when you request a ride, we have to find the right driver. So how do we predict the ETA for that? And also, how do we predict the eventual ETA to the destination? As well as, for example, if you need to get to the airport by a certain amount of time, then when do we need to start requesting for a lift for you? So it's a bunch of interesting, I guess I would call them edge cases for ETAs.
I've got a
Yeah.
question. Oh, sorry. Go ahead.
I was just going to say, one thing I'd add to that is an interesting question we've had discussions about on the team is how do you determine that a new ETA model is good? Like, how do we decide that this is actually good for the company? And as an example, say we have a new ETA model that makes all ETAs for all riders shorter by like 10 minutes. Riders would be really happy with that, right? They would be like, oh, like I should request this ride. Like this is a great ETA, right? But that actually messes up our entire marketplace because that's not an accurate ETA. We're not pricing rides correctly. We're not matching you as efficiently as possible. So that kind of leads us to question, what is the right way to evaluate an ETA model? And it often just comes down to the core accuracy of ETA and distance itself.
Right.
Pretty much partially answered before I even asked the question. My question was for you, Deeksha, with what is the experience like for being a tech lead that owns one of probably arguably the most important core fundamental model or systems of models that runs that business? Because just like you said, if you get that wrong, you could lose customers or you could seriously irritate drivers. There's a lot of weight on the shoulders of the team. What does change management look like there?
That's a great question. So there's a lot that goes into an ETA model update that has a phase shift in terms of accuracy. So like Michael and I, we recently worked on a project where there was a pretty sizable improvement in accuracy. And that wasn't something that we could just ship like that because we have other teams that have models that are coupled to ETA. So even if we have higher ETA accuracy, we need to make sure that we work with all of our partner teams, like matching, pricing, and make sure that they can accommodate for this change. Even though it is actually a good change for the company, we need to make sure that we're all aligned. So that's in terms of like sort of like business level metrics, like what we're tracking. But then there's also a lot of work around like basically when you request an ETA, it's not just when you request a ride, it's not just one ETA. There's multiple ETAs that come out of it, right? So like we have to match you to a driver. So we look at like K nearest drivers, which means we have to get K ETAs. And so Michael, as like the eng lead on ETA, he can probably comment on, how the scale of what we're working with here.
Yeah, sure. So we probably have about 30 callers into our service, and for a variety of different reasons or use cases. Like I mentioned some of them, matching fare, etc. And then as a result of that, we serve probably millions of requests at a minute level. So we have to be really mindful of not just the model accuracy, but also the reliability of the service. I would say also the other side of what Deeksha said is there's also a lot of guardrails on other teams to make sure that ETA changes are not impacting that much in the downstream dependencies. So for example, on the matching side, there are times when ETAs could hiccup and the service may face some unreliability issues. So they have a way to fall back into something that's also less accurate of a prediction, but that would still ensure that drivers could get matched to a ride and vice versa, riders could get matched to a driver.
So that sort of tiered approach, and like Michael and I have talked about it with a number of people who've been on the show over the last couple of years. Like, hey, you you hope for the happy path of the highest accuracy, most sophisticated model, but then you have a fallback on the data science side to be like, hey, if we don't return in enough time or something went wrong and our monitoring is saying that, hey, the model we're putting into staging or into production, worst case, we'll fall back to our version on our side of the API, and then downstream, everybody's got to have their own fallback logic as well. I think that's an important thing to continuously, on this show at least, for us to mention, like, hey, everybody does this who's doing this for real, because if you put all your eggs in one basket, that one model, and you don't have robust deployment going on, you're like, hey, we do shadow deployment for 4 hours and make sure that metrics coming back are good, or however, I don't know how you guys do it, but making sure that you have that cutover and reversion logic in to say things are on fire, move back over to yesterday's build or something. Yeah, I've worked at companies where people weren't doing that, and they're like, we're using ML, it's in production, and then something shifts, and like, everything is on fire. What do we do? So what's that process like at Lyft when you're, if you guys can talk about it, about deploying like a new fundamental new feature? Like you said, you just released an accuracy improvement. How do you go through that process of making sure that it's revertible?
I don't know if you want to take it first, Deeksha, or
you can go first. Go ahead.
All right. Okay. I would say this process takes quite a bit, starting from the model sort of proof of concept stage. So Deeksha can probably talk about that. And once we have somewhat of a confident model that we can prove the accuracy improvements offline, then we get into the phase of how can we roll this out, and how can we bring it into our own service, and then make sure all the downstreams can react to the changes that's caused by this model. So we basically talk to a bunch of teams. One of the most important teams that we talk to is the team that relies on ETA distance to set the pricing, because pricing has correlations with ETA distance as well. So we talk to them about, hey, there's this new ETA accuracy improvements. Can you guys make sure that this change is addressed in your model as well? So we work with them to train a new version of their model. And then we would, at that point, sort of figure out how we can get into experiment or A/B testing for the new version versus the old version for both models at the same time. And then in the experiment phase, Deeksha could probably talk about all the metrics that we monitor as well. We figure out whether the metrics are green, basically good, or bad. Sometimes they're a mix. And then we do an experiment review with the downstream teams, including the pricing team, and also the matching team, who's in charge of matching the right driver to the rider using ETA and distance, as well as figuring out what I mentioned earlier, what the right ETA to set when we don't even know who the driver is going to be, when the rider requests for that ETA. So there's these metrics that we look at, how that impacts the accuracy of these downstream metrics with our new versions. And if they look good, then we roll it out. And then there's obviously the process revertible. So we keep the old model in production for a few weeks, just in case something goes bad, so we can revert to that. I should also mention, before we get into experiment, we do this shadow phase where we have the new model running in shadow against the production, and then we can observe online what the performance of the model is and how that may affect downstream teams.
That's got to be crazy complicated for Deeksha to handle that concept of you've got a new idea, a new feature, you're putting new data in to say, hey, this is my hypothesis. I tested it. My model works really well. But then you're having to monitor 7, 8, 30 different consumers of your model, and then also having to think about your changes as they impact all of those and ingesting that validation data in that shadow deployment. How long does that take? Like when you're doing a new major feature, is this like you do 1 or 2 a quarter, or is this much faster development time?
We're able to ship, so it depends on the type of change. We're able to ship like feature changes to existing models pretty quickly. Like it could be like, if it takes like say like a few weeks to add a new feature, we shadow it for a few weeks. By the time we get to experimentation, we don't want to run an experiment on something that we truly don't know anything about. So when we go to experiment, we feel pretty confident that this is going to look good. It's not going to degrade business metrics, but it's more of a sanity check because, as you mentioned, ETA affects so many other services at Lyft. So we just need to ensure that other metrics aren't degrading. But yeah, like for simple features, additions to the model, it's not too bad. But when it comes to like fundamentally changing, like rewriting our entire ETA system, which is something we just recently did, that's something that's a lengthier process, and it requires a lot of buy-in from stakeholders, a lot of explanations, because we like in that rewrite, we were looking at like our experiment review. It was like probably like 40 metrics that we're looking at, and it's pretty difficult to improve 40 metrics all at once in one experiment. And so there's a lot of trying to understand like which of these metrics actually matter, which of these metrics, if they degrade, it actually doesn't mean that we're doing something wrong here. It means that we need to ask a partner team to fix something. So yeah, there's just a lot of like aligning stakeholders and getting buy-in from them.
How do you do stat sig calculations for 40 metrics?
So before we run the experiment, we do a power analysis to understand how long we would need to run this experiment for. So just given like an estimated idea of like what the impact would be on that metric, we're able to simulate it beforehand. So our ML platform is actually really, really solid. I know you guys interviewed them just like a month or so ago, and in there we have really nice tooling to understand, okay, what is the power of this experiment going to look like? Should it run for 2 weeks? Sometimes some of the metrics we're looking at, we just won't get enough power in 2 weeks, so we have to run it for 4 weeks. And then there's certain metrics where it's like we want to ensure like for example, we want to see like long-term impact, maybe in terms of like long-term retention of riders or drivers. For that, we have to go for longer experiments.
Right. And then you also guys, you implement something called surrogate metrics, right?
Surrogate metrics?
Cool. So I come from a company that did a lot of A/B testing, and specifically with similar two-sided marketplaces.
Mm-hmm.
And one of the big challenges is determining long-term impact of an experiment. And so I've read in some blog posts that you guys leverage a concept of a surrogate metric, which is basically a short-term metric that is indicative of a long-term trend. So what kind of metrics are like short-term metrics do you guys use to sort of estimate the overall business impact over, let's say, a year or even longer?
Okay, yeah, that makes sense. Well, for metrics like that, we're looking at sort of like there could be trade-offs in terms of change in like conversion versus change in profit. So it's like a per ride, is this actually like improving the experience of the rider in terms of like actually being more accurate, but is there a trade-off in terms of retention? And so we have some metrics that weigh that trade-off that are set by the company. They're not really set by like individual teams, and we just have to stay updated with their guidelines.
Got it. Cool.
We got a potentially super stupid question for you about features and testing. Do you try to model when you're doing a new release of something that you're not 100% sure of? Like you've done all the pre-planning and done, it sounds like you front load a lot of that design work to understand the problem before you write code, which is really good practice to do, and then work on the feature and then monitor it. But if you're doing a shadow deployment, say in March and checking, saying like, hey, we're deploying this in North America or in the state of California or something. Like we want to make sure that, you know, our services in big metropolitan areas are good. Do you try to estimate black swan events that are hard to estimate through some sort of simulation modeling? Like, hey, we want to estimate when a big sporting event is coming to a downtown metropolitan area. How is the model gonna react to that? Is that done in some sort of simulation environment based on prior crazy things that happened?
That's a great question. So digging a little deeper into our ETA models, we actually have one that updates in real time. So it retrains in real time. And that has been really, really useful for these kinds of issues where there are like major events or there's like a snowstorm, or, you know, even like major holidays like New Year's. Just sort of training on historical data, say it's like a month or 2 months of data, might not actually be reflective of what you see in production. So we actually have a final layer that's able to accommodate for that and just learn in real time about these sorts of issues.
That's fascinating. So stuff like a fire in LA underneath a bridge that completely closed an interstate, you're at the algorithm. When that happened, do you guys like sit around a computer and just watch in real time? Be like, how's our algorithm doing? Is it rerouting? Is everything changing? Tell me, you guys do that, right?
Well, when we rolled this out, I remember we were like, oh, like we should definitely track this new model because Halloween is coming up, and we definitely were sitting around watching like, okay, is this model doing what we expect it to do on Halloween when we're going to have a lot of traffic, a lot of closures? So yeah, we in the beginning that was definitely like an exciting little thing, and leads would be excited to be like, oh, like did the model accommodate for like there was a snowstorm in my hometown or whatever, like did it accommodate for that? So and we found it to be pretty robust so far.
That's got to be like this awesome feeling where everybody's just sort of looking around at each other like, we actually figured this out. This is awesome.
Yeah.
So Michael, I was wondering if you could elaborate a bit, or Deeksha, on the underlying infrastructure, because you guys are sort of at an interesting place in ML where you need really fast decision, and you also need to basically support, as you mentioned, millions of requests at a minute level. So what does your cloud bill look like?
From sense of how deployment works or how infrastructure is hosted on the cloud?
I guess more on the infrastructure side.
Okay. So most of our services are hosted on AWS, and we have Kubernetes clusters that is running on AWS EC2, and we have auto scaling units that can handle, I guess, load increases in real time. And getting into a bit more of the service that goes on to generate the CT at the end, because it's not just a single service or a single model that does this. So we have we're part of the mapping org. So within mapping, we have a team that is in charge of curating all the map data. So you can think of that basically like Google Maps, where you say, here are all the road segments, here are all the points of interest on those roads. So that's sort of our base map team who's in charge of doing that. And on top of that layer, we also have a team that is in charge of observing all the drivers' movements on the map and figuring out their real-time speed. And with those locations and speeds, we can calculate the traffic on those road segments, either over a long period of time or in real time, for example, the last 5 minutes. That's how we can determine congestions or traffic in certain areas. And using this traffic data, then we can come up with an accurate route for the drivers. So we have I guess a service that is in charge of generating multiple routes from going from point A to point B. And relying on the real-time traffic data, then we can figure out what is the best route for the driver to get from point A to point B based on avoiding congestion, for example. Or we also have real-time road closure data to avoid road closures. And like Deeksha mentioned, if there's an event going on, some road is closed or have traffic, we can use this to route the drivers more accurately. And then the last layer on top of the routes is our ETA prediction layer, where we generate an accurate ETA based on the I guess the starting point and the end point and the potential route that the driver is going to take. So we know we can recommend drivers a route, but we don't know that that's a route the driver is going to take eventually. So how do we predict the best ETA for our riders, knowing that that's the route that we're going to show the driver, but the driver has a chance to not comply to that route. So that's sort of the problem that the ETA model is trying to address. And maybe I sort of moved away from the infrastructure question, but I guess if you have some specific questions, I can answer. But
well, just one question. So you have sort of this layered model. Is it all in one database? If so, what kind of database, or do you have different databases to serve different use cases?
You're referring to the ETA model or the different
You talked about the
of
base map and then the driver sort of real-time map and then the routing layer as well. Is this all just in key value store? How do you store it?
Yeah, those are in different stores. So Basemap has their own store of the data, for example, for roads and points of interest. Those are actually in two different data stores, points of interest and the road segments. And in order for it to compute the road on top of these, I guess, the route on top of these road segments, we have to convert the data into, you can imagine a graph model. So we can perform Dijkstra search on this graph model. And this graph model sort of have to live in memory because Dijkstra needs to run in memory. So we take what is in sort of like an S3 long-term storage, and we convert that into a graph model and put that into our memory so we can run our route algorithm on top of that. And then finally, we have the ETA model, which is stored in memory as well in some other service. So I would say the data is pretty distributed and not just sitting in a single place.
Super. One thing that you mentioned about the drivers not selecting a route, I imagine it must be complicated when you're building route optimization if there are rogue drivers in the training data. Somebody who's like, yeah, I got this route that I'm supposed to take. I don't trust technology. I know this city. And they always take a suboptimal route. Do you have to detect stuff like that for retraining and say or mark it or label it in some way to say this person didn't follow our recommendation, or conversely, this person found a far more optimal route that beat the ETA estimation by 40%. Is that used in the analysis phase or in retraining, and how do you handle that?
So we own the full mapping stack, and I guess what that means is like Michael mentioned, we create our own map using a combination of open source data and some really valuable data we have in-house from like driver GPS traces. And so we're able to look at historical data and see we recommended these routes, but drivers are not going on these routes. And it's really interesting because we have been able to learn a lot about the map and even fix the map, this sort of open source map, by sending back edits to OpenStreetMap and saying, hey, this is what we call a ghost road. We believe this might be a ghost road. Like no one is going on this road. So there's this community that this sort of Wikipedia for maps called OpenStreetMap. It's used by other companies as well, like Amazon, Meta, Snapchat. And all these companies are contributing back with what they find from their fleet of drivers or riders. And then we're able to leverage that in our algorithms.
Interesting. And that'll also update stuff. Roads don't permanently close very often, but sometimes if there's some sort of major construction project, then that'll go in, you'll fetch that latest build on like a nightly basis or something to ETL the open source package in? Or do you do like strict version controls of, hey, this hash commit is what's in production right now, we only update after validation?
So yeah, we have, for the base map team, they have a lot of automated checks. So they download the latest version, and then they have automated checks by just looking at our driver data. So like if there's, for example, a road that does not exist in our map, but we keep seeing drivers are going somewhere and it's like off path, then we're able to run some validation checks like that. And we have, like Michael mentioned, a whole curation team as well, that's able to curate things and contribute things back. So it's become a pretty quick feedback loop from downloading to validation to submitting fixes back to open source. But obviously that's not going to fix everything. And so that's why we have these ETA models at the end, where they're able to account for uncertainty of accuracies anywhere in the stack.
Cool. So it sounds like the data are pretty good, and it's a slow and steady progress for improving this data. But Deeksha, you mentioned you guys rewrote a lot of stuff recently. What was the problem, or what were the problems that were addressed in the prior version, and how did you address them?
How should we dig into this? So basically, we launched our own navigation called LiftNav. So if you go on a Lyft ride, you'll see that majority of drivers, chances are you'll see that your driver is using something called Lyft navigation. And the idea behind our update was that, so drivers and riders, they want the most real-time information in terms of like closures, traffic, all of that. And so this big change that we had was in terms of like getting these high speed signals into our final ETA models, and basically unifying itself with this Lyft navigation platform, because with LiftNav, we're actually telling drivers where to go. We're deciding the routes now. And so it was a matter of sort of combining the fact that we know where drivers are likely going to go, and that we have all this traffic and closure data, and just creating a higher accuracy ETA model because of that.
It doesn't sound like a trivial change at all. If you're integrating with a whole new system, that sounds like a monumental data science, machine learning engineer, and just pure software engineering challenge. How many people were involved in that, and how long did it take to do the product design before a single line of code was written?
Are you referring to the navigation part, or integrating our ETA stack into the
integration? Like your team integrating with this entire new product feature.
Yeah, I would say we probably had, including both scientist, engineer, and data engineers, probably 6 people, 6 to 8 overall that worked on this project. And over what time frame? I would say 6 months to a year sort of time frame.
Sounds about right.
Yeah.
Based on my experience of like, hey, we have this new feature on the platform, it's time to integrate. We're like, okay, we're going to take a quarter and just do design and prototypes, and then we're going to iterate. And then by the time you're ready to release GA to like the public, it's usually about like a year for something of that size.
Yeah, I would definitely echo with that by saying that implementation was not the longest thing. The longest thing was, how do we get that model into production? How do we test it out? How do we make sure downstream is also ingesting these changes correctly? And also the long tail was like debugging. We had some version of what we expected offline, didn't see that online. And how do we debug through these, I guess, imparities between what we saw offline and online? That also took us quite a while as well.
Can you give an example?
Yeah, so one of the things was we have different ETA and we predict both ETA and distance. And we have ETA distance metrics like ME, MAE, RMSE that we monitor offline and also online. And when we rolled this model out into Shadow, we noticed that for distance, the metric did not reflect what we saw offline at all. So we had to dig into whether that was a data issue or a model issue or an offline parity issue. There's a variety of different variables that we need to make sure that is performing as we expect them to before finding out what um, I guess, where this fix should be in before we, I guess, roll this out even into experimentation.
And
Okay.
there were some interesting ways in which we debugged that. Like at one point we were like, okay, let's just like send from our service. Let's always just send the same value kind of thing. Like always sending out a distance prediction of X in Shadow, not in production. And and we're like, okay, now let's trace all of our tables and see what's going on. So we had to kind of dive deep in order to find the issue.
Got it. And Ben, in your experience, is this common when you're rolling out from Shadow to prod, or does it always work perfectly?
In my experience, again, with all the models I've ever shipped to prod, back when I was doing data science work, the exception was when it went well, and that set off an alarm in my head saying, I'm not seeing where it's failing. I need to dig deeper, because I've never shipped anything into a staging environment where it works the first time, like as expected. Maybe I'm just bad at what I do, but usually these systems are so complex that it's like there's going to be something that's unexpected. And if you don't get alerted to that right away, that means it's probably an insidious bug that like your CI isn't catching, or you're just not realizing what this impact is potentially going to do. And then moving to the pure software side in recent years for me, um, I mean, we ship bugs. Everybody ships bugs, and it's an opportunity to learn and write more robust testing infrastructure and make sure that it never happens again. But it's pretty rare for a feature of that magnitude of what the two of you just explained for that to go well in sort of that shadow mode of production deployment. I've never seen it, like not even one time, where it just something that takes a year to build. And even like if you're to sum up the number of incremental changes and say, okay, during every incremental test that we did, these private previews, there were no bugs. I've never seen that. That would be
Yeah.
so abnormal that most people everybody that I work with would probably get into a meeting room and say, what's going on? What are we missing? And they would kick off like a very intensive bug bash to figure out, like, are we being stupid here? Like, let's figure this out. And I've never seen that, like people gather like that, but I've seen hey, everything seems to be working fine. And they just tag another person to get fresh eyes on it that doesn't have context. And they find within like the first 5 minutes, this API is broken, or, hey, I'm doing this one thing. Look at this crazy stack trace. I have no idea what's going on. We're not catching this exception correctly. So there's always something that you can find with fresh eyes.
Got it. Okay, cool. That makes sense.
I think there's one example I can probably give you about something we found that was very interesting. So in the shadow data, we noticed that for rides that are less than 1 minute long, our model is predicting something that's like 5 minutes, or something that's just not reasonable if it's just around the corner, for example. And we noticed that we didn't see this in the offline data, because in offline, when we train or when we evaluate the model, we filter out some of the rides. And these were the type of rides that we filtered out. So as a result of that, we kind of had to build logic into our service to say, hey, just don't predict for routes that are less than 1 minute long. because the prediction is probably not right. And we don't need a model to predict for a route that's very short because we kind of know that it's going to take a minute. So that's something that's we didn't see offline, but we saw online. I had to really dig to find out what was going on.
Do you hard code those values, or you still use dynamic modeling? Like if it's under 10 feet, just call it 0 minutes.
When we looked at the bug, we did some dynamic search to find what the best value to set.
Got it. Very data driven of you. I like it.
So that's filtered out from training data, but just due to the sparsity. Like, hey, how many times do we have a 16th of a mile ride? And is that because somebody signed up to go 20 miles and then they just bailed out because they didn't like the driver in the first 200 feet and say, pull over, let me out?
There are situations where the driver's just around the corner. So the data would be from the driver's location to that pickup. That's a very short ride. There are situations where the driver's behind the rider and they have to go around the block to get back. And the model doesn't learn that. The model thinks, oh, they're very close, so I should just say 0 minutes. But actually, in reality, the route the driver has to take is going around in a circle, then come back. Maybe that takes 2 minutes. So there are situations like that where the model may not perform as well.
So the local navigation due to architectural and design of inner city traffic is what messes that up. That makes total sense. I remember being stuck on a corner when using your service because of the design of Toronto city streets in one particular area, and it just had this really weird combination of one-way directions and then a highway off-ramp immediately at where I was trying to pick up, and the driver was sending me messages saying, can you go to the other side of the block? It's going to take me 10 minutes to get there. And I'm looking at the map. I'm like, he's like 300 feet away from me. Like, how is that? And then I looked at the street signs around me. I'm like, oh, yep. Okay. And as I walked over, I was like, okay, now everything says, the correct ETA, and they were right there. But yeah, that must be incredibly challenging to detect stuff like that in training data.
Yeah. So we've been talking a lot about edge cases, and a question for both of you. What excites you about ETA? It seems like you spend a lot of time in the mapping space. Do you like working through all these subject-specific edge cases, or do you like building the infrastructure? Like, what about the job and the subject matter is exciting to you?
Maybe I can go first. Like you said, Michael, at the beginning of the show, that ETA just goes into so many things at Lyft. It's very fundamental to the business. It's fundamental to the user experience. And I think it's very rare for me, just looking at any product, to find a team that's crucial to both the user experience and the business, and to have like so many other dependent teams on that one single product. So I think that makes the space very dynamic. I'm still learning new things every day, even though I've been on the team for almost 5 years. I was talking to a person from the pricing team, and they were telling me yesterday that they do to detect for fraud. They would send requests after a ride happens to see if the ETA prediction after the ride is the same as the ETA prediction during the time of the ride, to detect fraud for riders that may find loopholes in the system where it always gives them $20 off for some reason. So that's a use case that we never thought that would be used for, but that's what the callers are calling us for. Or during the middle of the ride, when at the rider request for a new destination or like a waypoint where they need to go to the grocery to pick something up, they need to predict ETAs again. So that's another use case that we sort of need to handle and make sure that we have accurate predictions for. So yeah, I guess I'm just learning new things every day, so that makes it exciting and not boring.
It's got to be. Oh, sorry. Go ahead.
Oh, go ahead.
No, I was just saying, like, it's got to be really fascinating as a design principle how your team has designed this to say, we're behaving almost like a sub company within a company and providing a service. It's almost like a SaaS service. You're saying like, we don't know how people are going to use these APIs, but we expose them and you can hit them. I was just saying that's a fascinating way to handle it, and it's a scalable way to handle it too. Instead of having to say, we have a monolith, everybody has to embed their logic within this stack for all of these use cases. Good luck maintaining that code base with 30 different divergent paths through a single endpoint. Sorry, Deeksha,
Yeah.
go ahead. What you were saying?
Oh, I was just gonna say, I think another nice piece to it, just to add to your point, actually. So there's all these, we have to think about all these different services, and that leads to sort of this like really high-paced environment in terms of we need to be thinking on our feet, we need to be quick debuggers, and I think I just really like practicing that skill set. And there's also just like, everyone I know like uses Lyft in some way or another, right? So it's just like whatever we ship, it's like, okay, this is going to touch my friends, my family. So there's an element of, I don't want to mess this up because these are people I care about. So I don't want them to have a bad experience. And it's cool having the ability to sort of to work on a problem that does that.
Yeah, you sort of take more pride in your work because you know that your grandma is going to be taking a Lyft and you want her to get there on time and safely. So that definitely resonates. Okay, cool. And Ben, I know you have to drop, but I think I have a couple more questions. And one of those questions is basically, how did you get to where you guys are from a skills perspective? So you hold very prestigious positions at a prestigious organization, and theoretically you are good at your job and know what you're doing. So how did you get there?
How did I get here? I think there's just a lot of like constant learning for me. So, and staying curious. So like outside of work, taking classes on Coursera just to sort of stay up to date. But then at work also just like asking good questions and trying to find out which team is of interest to me. So yeah, I think it's just a matter of like staying curious and staying connected with people within your company or with outside, like having a strong network. That's been really helpful for me to figure out, like, find work that actually really excites me.
Got it. So follow your passion. Is that the sort of
Yeah,
one line?
I guess follow your passion, but also like, I think for me, it's like the people I work with matters a lot, and like feeling like I can learn from them, and that we have this sense of like we're all really interested in this problem. So it's like I think I would struggle with working on a problem I'm passionate about, but with people who are not passionate about it themselves. So finding an environment where other folks are also excited about what they're working in.
And it's so, if you're so people focused, did you have a hit in terms of productivity and job enjoyment during COVID?
Definitely, it was tough. I mean, when we were in the office before COVID, it was so fun. The whole office is pink, and we would just, yeah, we would go in, and like it just really felt like a fun environment. So COVID was definitely tough, but I think folks tried to create an environment that is like decent, like decently social, in some way or another online. And now we're back in the office. So folks go in. It's not the same in terms of frequency, but people definitely go in.
Cool. Okay. And what about you, Michael? What excites you at Lyft? And well, I mean, more specifically, like it sounds like Deeksha has followed passion to get good at what she does, but have you followed that same sort of uh, curiosity, or have you grinded through and read textbooks and practiced on leak code? Like, what's your strategy?
Definitely practice on LeetCode to get here. That's for sure. Textbook in school as well. Although I've never been good on like reading textbooks that's assigned to me, I'd rather doing problems, just get more hands-on experience. But before I found Lyft, my requirements for the next job was like I wanted to work on a product that people use and a team that works on the product that people can see. And I also work on ML automation or infrastructure related work. Um, those were the requirements that I had before I found the job. And then when I found ETA, I was like super happy that it met everything that I was looking for. And I think I alluded to this earlier as well. It's that I've been here 5 years, and every year there's a different challenge. There's new lessons to be learned. There's new people to work with, like Deeksha said, and there's just the space is so dynamic, and we focus on a variety of different things, and we always need more people to work on these challenges. And like I said earlier, we're also finding out new things every day. So how do we make sure that we address for these new use cases in time? So these are things that keep me challenged and keep me engaged. And I think as a result of that, um, I just do work because I'm curious and I want to learn. So very similar to Deeksha's answers, I'd say.
Cool. And so both of you guys discussed the excitement of the field. Do you think the future of ETA is going to be algorithm based or improving data quality? Like what are the frontiers of ETA over the next 5 years that will be hopefully surpassed?
That's a good question. I would say it's like across everything, like eng, modeling, data eng, everything. In terms of modeling, we have some exciting projects we're working on in terms of understanding like P95, P99 cases, like how do we improve the sort of like outlier experience? And that's something that we've been pretty focused on lately. And also looking into sort of industry papers on what other folks are doing for ETA, and making sure that we're also somewhere close to what they're building. So yeah, those are the interests in terms of modeling. Michael, you want to take the other ones?
Sure. The other ones I would say are also making sure that we have a good story around all of the edge cases. So one thing I mentioned at the beginning was like, if a user says, I want to get to the airport by 10 o'clock, how many times can we actually guarantee that they get there maybe even 10 minutes before? Or, making sure at least that they're not late. And how do we make our ETAs efficient enough so that drivers can always be assigned to the passengers, or passengers can always get a ride within, for example, 5 minutes or whatever promises we make. So I think from the engineering side, it's addressing for these, airports use case, schedule rides use case, and the other internal use cases I mentioned for fraud detection, that kind of stuff. So having a good story around all of those different use cases. Yeah.
Okay. Notice, audience, that LLMs are not in there anywhere, unfortunately. But yeah, okay, cool. That makes sense. Do you have any advice for people who are potentially in the ML space, and if they want to get into more exciting roles, how they would go about doing that, and like how they go about building the technical acumen that would allow them to do that?
Take classes, I would say. I was taking some classes online as well, to just understand the model space. And technology is constantly changing, so keeping up to date to the new technology and new libraries, LLM is something that maybe we'll look into for ETA prediction. Who knows? And to get into the ML space, I would say also find a team that can support that growth is very important. When I came into Lyft, I didn't have any previous ML experience besides the courses I took undergrad, but I had enough trust to work on starting off at the very beginning with some automation for ML infrastructure, and eventually got more familiar with modeling side. So over time, I just pick up more, I guess, expertise in the ML space. But to start off, just finding a manager or a mentor that really supports you on that journey is really important, I would say.
Yeah, I also think I was pretty surprised in industry by how much folks will like trust you as long as you're motivated and really want to solve something. Even if you don't have the experience for it, people just trust you because you really want to do something, and they trust that you'll do a good job. Sometimes more, maybe even more than you might trust yourself. But I think finding people like that who will like are your ally, and that they'll just kind of allow you to explore new spaces. Or I think we have a lot of that at Lyft. We have managers who are willing to. It's actually like part of our sort of career development is we have these like individual development like programs with our managers where it's like, okay, like what are my growth areas? It could be like, I want to learn about reinforcement learning, and then your manager helps and find you a project in that space if possible. So having that space where you can actually do that is really nice.
That's super cool. And do you think the organizational rationale is for retention, or is it for seeing the ROI on skill sets and having you grow into a more seasoned developer, or both? Neither?
I'd say it's a combination of the two. I think the company really benefits from having folks stay because there's just like so much knowledge you gain as you stay at the company. But also it's just about like as a result of like having happy employees, and you're able to actually like hire other happy employees too. So it's just like it's one of those things where it's like you don't really see a direct, if you create this program, you wouldn't really see a direct ROI, but I think implicitly it is there.
Okay, cool. So one final question for both of you. What is the worst thing about the ETA platform at Lyft, and what is the best thing?
Worst thing and best thing.
And to add a little flavor, it can be about your interaction with it. It can be about the user's interaction with it. It can be anything. Like, what do you not like about it, and what do you like about it? What are you maybe proud of? What are you maybe embarrassed about?
I'd say, oh, go ahead.
Go ahead.
Okay.
Okay.
I'd say the worst thing is that it can be difficult to debug things at times. And so we have a lot of effort around debuggability this year. We've had it last year. I think we have it every year. We have a whole like project around debuggability, but it's still never really like an ending problem for us because we, like I mentioned earlier, for each ride request, there's just so many different ETAs. And so another team comes to us and they're like, this looks really bad. Why is this bad? It's like, okay, we have to like dive deep into our tables, be like, is it a map data issue? Is it an issue with the routing engine? Is it an issue with our ETA model? So that's always been a difficult process that we are trying to fix in different ways. Best thing is, I think the scale of the problem. I really like that, and how we have to keep a pretty like good overview of like who our callers are and be able to make adjustments to it despite being in this like difficult position where it's like, good, we want to improve accuracy, but we don't want to degrade business metrics, and we want our partner teams to be happy. So it's like, I actually like, that could be a con, but I actually really like that because it adds more challenge to it. And yeah, so it just makes it more exciting.
Got it. A couple questions on that. In terms of debuggability, so a core issue is that there's many disparate systems and each system is incredibly complex. And then on top of that, there's many different routes which depend on many different systems. So it sounds like one potential solution would be like testing each component super thoroughly so that you know inputs and outputs are not going to produce something that is problematic. and then also maybe like complex stack traces or something. But like, what tangibly are you guys doing to make debuggability more possible?
We log everything. Everything
So
we
you
possibly
guys just like read every like tons of
we
logs. That's
we have
really
a ton of logs, and then it's like, okay, we have all these logs, like how do we organize these logs? How do we, like, we've created like visual tools to debug these logs, like so yeah, I think that the first step is just logging everything, but then the next step is making sense of all the logs. And of course, like you mentioned, it's like we need to be careful with each update we have across the stack, but we can't really do everything. We can't like stop all work in mapping while one model is being updated. Like we have to be able to ship things in parallel, or else we're just really going to slow down as an organization. So that's why logging is really the best way for us.
got it. And are there like logging standards that are ridiculous and super complex, or is it pretty simple? Like, is the user interface problematic, do you think?
I think it's kind of, there are some guidelines, but for the most part, we have free reign on like how we want to log things, which is really nice. So like we'll often completely change it or rewrite our tables once there's like new business needs.
Got it. Okay, cool. Thank you. Michael, what about you?
I'll add, we have run into issues where we log too much and we have to cut down on the logging. That's one of the complaints from our infra team. So that's something that we have to juggle with as well.
Like a cloud cost thing or like a query latency thing?
Like a streaming platform cannot handle the amount of things we log,
No.
kind of thing.
Gotcha. Okay.
Yeah. Right. The best and worst. I would say I could probably give one answer for both, and it's the uncertainty. So the uncertainty in the sense that we just never know which route driver is going to take, and we can always do our best guess. We also would never know which driver is going to be assigned to the writer at the very beginning of our prediction, and we can only do our best estimate. And over time, we gain more and more confidence, though. So after the driver is assigned to the writer, we sort of get rid of that variable. And once the driver starts on the route, they more or less adhere to that route. So we also gain more confidence. So it's a matter of like, how do we address these uncertainties at different phases while making sure ETAs are sort of consistent, right? Like you can imagine if we don't know the driver, we can say, oh, it's 10 minutes. But once we know the driver, it could come down to 5 minutes. How do we make sure that user experience isn't compensated or is compensated correctly for like this gap of uncertainty and this jump between two different phases in that? So that's a constant problem that we're trying to solve. But I think it also makes it exciting because it seems like a never-ending challenge in this space. And there's always new ways for us to get around that. One of the things that we have done in the past is with the introduction of LiftNav, we can control our routes. So we can better control our ETAs with those type of routes. And our ETA predictions become more accurate with being able to control these route suggestions. So, yeah.
Got it. So yeah, if the prediction is different from the route, just change the route.
That's a good point. Yeah, maybe.
Wait, actually, like double clicking into that, that's an interesting thing to account for in terms of assessing model quality. How do you guys think about it?
Assessing model quality. So we have, like Deeksha mentioned, we have these metrics that we track whether there's a defective write in the sense of, is our ETA prediction off by more than 5 minutes, for example? And how good is our average prediction? So we have metrics like these to help guide our, I guess, research and our engineering focus to make sure that we're focusing on the right components of the system to solve and to improve these metrics over time.
Yeah, but the question was if the prediction has structure to it and fundamentally could change based on like new routing strategies, do you just quarantine that as like a weird data set section that needs to be handled differently, or how do you handle that?
So are you saying that there's routes that a driver can possibly take that we just couldn't predict, how does ETA address for those routes that the driver could take that we just didn't predict for?
Yeah, I guess fundamentally, you have a prediction for a route, and then that route will dynamically change. So it's not a static prediction. Is that an issue?
I guess there's two things. The one is we have a route and the driver just goes along this route.
Right.
And even if they do, that ETA can still change because the traffic pattern changes, etc. And so we have different layers to address for this. There's the traffic layer, there's also the ETA model layer, and the real-time ETA correction layer. The other, I guess, issue is the driver could be going on this route and they all of a sudden make a turn where we didn't say to make a turn. And in those cases, we just have to recompute the route based on where we think they might be going and readjust the ETA based on that.
Got it. Understood. Okay, cool. Awesome. So I think we're at about time. I will summarize. Lots of really cool things in this discussion. Honestly, a re-listen is probably your best bet. But in terms of model graduation and validation, typically at Lyft, they run into shadow phase or shadow deployment, and then they kick off an experiment where they look at complex metrics that are sort of indicative of this two-sided marketplace. And then the business decides the trade-off between potentially combative or at odds metrics. And this is at an organization level. From an infrastructure perspective, Lyft uses AWS with Kubernetes and autoscaling. And then they have this really cool layering of a base map. And then on top of that base map, there's drivers or traffic. And then on top of that, there's possible routes. And this is an in-memory graph model. And then finally, the ETA comes in with a real-time correction layer. On the career tips side, constantly learn and stay curious. You should focus on the people, whether it's just for brainstorming or camaraderie or just learning about new things. And it also makes your job more fun. And then when looking for jobs, it's important to be clear on your priorities and expectations, know what are deal breakers. And especially if you're early, at least in my opinion, sometimes just jump in and see what you like. It's useful to gather those data points. And then finally, on the big stuff side, one of the issues for the Lyft infrastructure is handling how complex that infrastructure is and debugging it. So their strategy is logging everything and creating sort of tools on top of those logs so you can easily parse them. And then another challenge is sort of handling the structured uncertainty in the time series of a ride. And so the way that you guys are handling that is introducing new rules at different phases of the journey and being dynamic. But ETA is a fast-moving space and a challenging space, and I'm sure there's going to be lots of cool things to come. So if people want to learn about those cool things to come, Deeksha and Michael, where should they go?
There's a lot of blog posts on Lyft.net. We have blog posts there. We also have blog posts on Medium. So those are your best bet.
Cool. And then if they want to get in contact with you or potentially a hiring page on Lyft, where should they go?
I think it's on Lyft.com, but they're also welcome to reach out to either Michael or me.
Cool.
Yeah, Lyft.com/careers. I'll plug that we are hiring. The entire mapping org is hiring. So definitely feel free to reach out to find out more information or just apply online.
Awesome.
On LinkedIn, yeah.
Great. Cool. Well, until next time, it's been Michael Burke, and have a good day, everyone.
Thank you.
Thank you.